My talk this afternoon is titled From One to Many, and what I'm going to be doing is to consider a problem that has engaged me for a great many years, which is the origin of many celled life from single celled life. Amoebas are examples of single celled lives. We are example of many celled lives. Now, over all these years, certainly since the time of Darwin and Wallace, the feeling has grown that any explanation for a phenomenon of this kind, in this case for how single celled organisms became many celled organisms, any explanation for this kind of thing has to involve a principle known as natural selection. Natural selection is the theory of evolution which Darwin and Wallace first proposed, and ever since then, ever since the 100 plus years that they put it to us, it has served as an extremely powerful explanation for evolutionary change. However, there are older theories of evolution which are also at the same time newer, meaning post Darwinian theories of evolution, which do not depend on natural selection. Rather, they depend on the same kind of explanation that we use to describe the world around us. And these explanations depend on physics and chemistry, or if you wish, physics, chemistry, and engineering. What I'm going to try and get across in this talk is that the explanation for how single cell life became many cell life, while it does have a lot to do with natural selection and therefore with the role of genes, also has a lot to do with the way in which single cells can interact with each other as cells. In other words, it has to do with the physics and chemistry of intercellular interactions as much as with genetic makeup. That is approximately the substance of my talk.